All right, hey scholars, this is Mrs. Gregerson. Now we're going to go on for the second half of lesson 1-4 and 1-5, and we're going to talk about angles. Now there's a lot of the fact that you've had angles before, and you're going to see a lot of different things by me, but I need you to understand we're going to go back to the basics so we can build on the more complicated parts for you. So let's do the first thing here. First of all, let's get the formal definition of what it is. It says an angle is a figure formed by two rays, which we call sides, okay, with a common endpoint. And that endpoint we call the vertex. Now that seems like way too easy, or maybe, you know, whatever, but understand how it's drawn. You see the two rays coming off, and this is a little bit easier to see actually on your notes than actually here, but you can notice that there's a point right there, and there's the letter R. That point is your vertex. And I'd almost prefer to say it's a figure formed by two non-collinear rays, so the ray's not formed from the same line, except for the book has a different definition of this angle, and we're not going to go into huge differences. But we need to be able to name our angles. Now here's the big thing that's most important. An angle is really named by its vertex. So if it's lonely all by itself and no other angles being formed, does everyone understand there's no other angles here? Well, we name it angle R. And you'll know right away, look at the symbol that I use. It's an angle symbol. Like I said, think about how original we are in geometry. You have a line for a line. You have a ray for a ray. A line segment for a line segment. Ooh, angle for angle. I mean, notation is very simple. So we have angle R. Now, some people will put an arc right there, just so you know they're talking about an angle, not an L. Very valid thing to do. Now, we also can play la 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 la, la 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 la, connect the points. Because when you name it, you want to name it to connect the points to form the figure that it is. So one way of naming it, but you have to always, always, always have the vertex in the middle. You can go S, R, T, and you know, S to R to T. Then we have our other angle. We have T, R, S. And understand, the vertex, the common endpoint, is in the middle. That never changes. Now, sometimes when you get a very complicated diagram, like a diagram like down below, where you have more than one angle coming off, you sometimes use a single number for it. So this is also angle 1. So right away, that angle has 4 different possible names that it can be referred to. You'll hear me refer to angles all 3 ways. Okay, either within 3 points, the single vertex, or angle 1. This one I don't use as much when we get into more complicated problems, because if there's more than one angle, and let me give you an example, like here's one angle, but the instant I put this other angle on here with that vertex, I can no longer say, let's call this one angle M. I can no longer say angle M, because am I talking about this angle, or the big angle? I don't know. So that wouldn't be valid for this picture. So we want to make sure that's the case. All right, and then we keep working. And we have the set of all points between the sides of it, we know is going to be called the interior. And obviously the interior is inside. So if you were to close the angle, think of it like on a hinge, that would be your interior. And everything on the outside of it, if you were making it, you know, like this way, it's going to be exterior. So pretty simple to do. Here's the important stuff that I was telling you earlier. You cannot name an angle just by its vertex if the point is the vertex of more than one angle. In this case, you must use all 3 points. All right, all 3 points to name the angle. Now, next one. What are the possible angles in the given diagram? Well, I want you to be able to see every single possibility. Now again, here's our problem solving. What do I have? Well, I have a pretty complicated diagram that has a whole bunch of angles. Where do I want to go? I want to name all the different angles. Well, how am I going to get there? I'm going to get there by going through the process of playing connect the points to form it. And notice A is going to be used every single time when I name this one. Now you're going to see me kind of do an orderly process because I don't want to undercount or double count things. So I'm going to do all the small ones first, going top to bottom. So I'm going to go angle, BAC. Remember, connect the points, BAC. I'm going to go angle, and I'm going to go CAD. And then I'm going to go angle DAE. So does everyone see that we got the smaller ones? Now let's see if we can get more angles using angle the side that has B as one of the side points. How about if I go angle BAD? Do you see I went from to the middle sized one? So we have angle BAD. And do you agree with me we could use the larger one and get angle, if everyone's with me, BAE. So we have those. Then let's start with C. Now someone goes, can I go CAB? Well, no, CAB is the same thing as BAC, so I'm not going to go backwards. But I can go one more and get angle CAE. So I'm going this way. Now, are there any other ones that I can get here? So I'm looking it through and I'm thinking, is there any with E that could be different? I could go EAC, but that's really the same thing as CAE. It doesn't really matter if which one's first, E or C, as long as A is your vertex. So that's not really helping me much. So I'm really thinking we've got all possibilities right here. Kind of cool, isn't it? All right. We're going to go to the next page and we're going to talk about how to measure it and the correct notation from when you're talking about its measure.